Okay, so now let's talk about time series graph in Math 23. So the first row here is 1, 2, 3, 4, 5. It could be weeks, hours, days, months, years. Okay, so normally we use x-axis for the time. Okay, so let's say this example 1, 2, 3, 4, 5 means weeks. Okay, weeks. So then we label them on the x-axis. So that's the easy part of the graph. 1, 2, 3, 4, 5. And the meaning of those numbers are weeks. Okay, are weeks. So now the harder part is the y-axis. Okay, y-axis. The most important thing is the maximum value for this second row. Okay, second row. And these numbers could means books you read per week, miles you run per week. Okay, so different meanings. Okay, different meanings. So what's the maximum of this second row of the part for y is 25 for this example, right? Maximum is 25. So for this graph, we just need to make sure 25 is on the y-axis. Okay, so we should choose something near 25 to be the top. Okay, so most cases we choose multiples of 5, multiples of 10. If it's a small number, we will talk about that later. Okay, talk about it later. So now 25 is a good number, so we just pick the maximum is the top of the labeling on y-axis. Okay, and normally we cut the y-axis, the positive y-axis to 5 to 10 parts, right? Yeah. 5 times 5 is 25, so let's cut it to 5 parts, right? 5 parts. So first is 5, and then is 10, then is 15, then is 20. So every gap here on the y-axis is 5. Okay, it's 5. So it starts from the maximum 25, and then we decide how many intervals, how many small gaps that we want on the y-axis. Okay, and then we know how much for a single step, a small gap. Okay, a small gap. So now to plot the point, right? We have to label these 5 points, right? Label these 5 points. So every pair x, y is a point, right? So now the first point, it will be point A, so which is 1, 15. That's the first column. And then B is 2, 5. C is 310. D is 425. And E is 520, right? 520. So now we can plot these 5 points on the graph, okay, on the graph. So sometimes we have negative numbers, but in most cases in Math 23, we only deal with positive numbers, okay, positive numbers. So let's look at point A, 1 for 25, 1, 15. So we go to number 1, and then we go up 15. We go up 15, so this is point A. Right? B is 2, 5, so B is much lower. B is here. C is 3, 10, so C is up a little bit, about number 3. Week 3, 4, 25, so that's the maximum, right? 4, 25. So this is C, this is D, and then the last one, 5, 20. So this is E. Okay, this is E. So after you plot 5 points, you can use a curve connecting A, B, C, D, E to look at the trend to get some conclusion from these 5 points. Okay, these 5 points. Okay, yeah, so normally we put time, weeks, days, years, months on the x-axis, and then the other value, given value, numbers, will be the y-axis. The easiest case, we just use maximum. Okay, so this is our second example. So we still use 1, 2, 3, 4, 5 weeks for the first row, so that's the same x-axis. So now the y-axis, we have decimal numbers, and they're all around number 4, right? All around number 4. So now what's the maximum now? So the maximum for this second row is 4.5, right? 4.5. So it's the second week, right? It's the second week. See? Yeah. So now suppose we still do this example like before. We just look at put 4.5 here as maximum. That's the top of the y-axis. Then from 0 to 4.5, right? So we may choose 5 intervals from 0 to 1, 2, 3, 4, 5, or we may choose 9 intervals. 0.5 is a gap, so 0.5, 1, 1.5, right? Yeah. So let's try to do that. So this is 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, and 4.5. Okay, 4.5. So I didn't do a good job on the y-axis. Okay, on the y-axis, because all these cutting points supposed to be even, right? Yeah, same gap, same length. Okay, same length. So now if you plot these 5 points, so you will see a trouble, right? You will see a trouble. So this point A is 1, 4.15. Point B is 2, 4.5. Point C is 3, 410. Point D is 4, 4.25. And point E is 5, 4.20. Okay, 20. So now they are all around the height between 4 and 4.5. Okay, so this is our A, a little bit higher than 4. B, 4.5. C, 4.10. D, 4.25. And E, 4.20, right? 4.20. Okay, yeah. So they are almost on the same horizontal line. So if you're connecting A, B, C, D, so it's like a straight line, right? It's like a straight line. So if we only use maximum, this is not a good graph. Okay, not a good graph. Okay, so now let's start again. Let's also use the minimum. Okay, let's use the minimum. So we use maximum and minimum to rescale the y-axis. So let's put this on top of the slides. Okay, so use maximum and minimum to rescale the y-axis. Okay, y-axis. So maximum we know is 4.5. So what is the minimum? Minimum of this second row is 4.10, right? 4.10. Okay, 4.10. So now we will put maximum at the top of y-axis, 4.5. And we will put minimum just a little bit above 0 on the y-axis. Okay, y-axis. And then we draw some wiggle line here, so that means we forget about everything under the minimum. Okay, so we press everything below 410 down to a very small part in the y-axis. So this will maximize the gap between 4.10 and 4.5, maximum and minimum. So now in this case, we just need to label all the numbers between this minimum and maximum. So from 4.1 to 4.5, so it's easier to label, right? We put 4.2, 4.3, and 4.4. So from minimum to maximum, we cut it to 5, 4. 4 intervals, okay? And each interval is just 0.1, okay? The 0.1 is the gap in this new labeling, rescaled y-axis, okay? Y-axis. So we didn't look at anything above 4.5 or below 4.1. Okay, 4.1. So that means rescale y-axis using maximum and minimum. So now where is my A? So my A is 4.15. So this is my A, right? The height is between 4.1 and 4.2. My B is 4.5, so this is my B. My C is 3, 4, 10, so is down here. And my D is 425, so this is between 4.2 and 4.3. And then 420 is my E. Okay, my E. So now let's use yellow color to connecting all these 5 points. So now the curve is much more clearer. Okay, much more clearer. So this is called rescaling. Okay, rescaling. We rescale to only look at the useful part, to maximize, to amplify the difference. Okay, the difference. So that's the second part. Okay, that's the second part. Okay, so now let's talk about cumulative frequency. So by definition, that means you add all the frequencies in that class and all the class before that class, all previous classes. Okay, classes. So for example, in this table, so let's make a new row for cumulative frequency. So for week 1, cumulative is 15. For week 2, we need this week number 5 and week 1 15. So it's 15 plus 5, 20, right? 20. So week 3, we need this week number 10 and everything before that. So it's 20, right? It's 20. So this is 20 plus 10. Third week and the first 2 weeks give us 20. So we got 30. Okay, 30. So the week 4 we have 25, and then everything before week 4 the total is 30. So for this one we get 30 plus 25, 55. For week 5, so all previous classes we got 55, and for week 5 we got 20 more. So it's 55 plus 20, 75. Okay, 75. So we make a new table by adding this new row for the cumulative frequency. Okay, cumulative frequency. So now sometimes we can use weeks and the cumulative frequency to make a graph, which is also maybe useful. Okay, maybe useful. So now let's draw the graph. So same thing for x-axis. That means weeks 1, 2, 3, 4, 5. So now what's the maximum? So this y-axis will be the cumulative frequency, right? So what's the maximum now? Maximum for this third row, max is 75. It's the last one, okay? Because that's the total, okay? That's the total frequency for all 5 weeks, okay? Yeah. So now let's label the y-axis. So maximum is 75. So now let's choose the gap, right? Let's choose the gap. So 15 is a good choice, right? So 15, and then the next one's 30, and then 45, and then 60, then we get 75. Okay, 75. Okay, so each small gap on the y-axis is a 15, right? Is a 15. So now let's plot the points, right? So the first point is 115. That's my point A. A is 115. So B is 220, right? Second week is 220. C is 330. C is 330. So this is point C. This is point B, right? Point B. And then point D is week 4, 55. So it jumped much higher, right? This is point D. And finally, we got point E, so that is 575. So that is E, so this is 575. So now let's connect these 5 points, A to B, B to C, C to D, D to E. Okay, D to E. So in the beginning, it go up very slowly, but around 4th week, okay, it go up much faster. Okay, go up much faster. Okay, yeah. So my picture is not that good because I don't have space. Okay, I don't have space. So B and C is supposed to be a little bit lower. Okay, a little bit lower. So that's the graph. Okay, that's the graph. Okay, so now let's talk about some calculations. Mean, sample variance, and sample deviation. Okay, so mainly we need a table. Okay, we need a table, but before we find the table, we have to find the mean. So most cases we use X bar for mean. Okay, yeah. And this is the row for X, right? This is the row for X. So now we're not talking about XY plane. Okay, it's just a simple calculation for the given numbers. Okay, for the given numbers in the second column. Okay, so what's the definition of mean? So X bar is the sum divided by how many numbers in the second column, in the second row. Okay, second row. So that's 5 numbers. So divided by number n. Okay, yeah. So the total is 15 plus 5 plus 10 plus 25 plus 20 divided by 5. So it's 75 divided by 5. We got the mean is 15. Okay, the mean is 15. So mean is the total of all given numbers. In this table, there are 5 numbers because we have 5 weeks. Okay, divided by how many numbers in this second row. There are 5 numbers, so divide by 5. So the average is 15. Okay, the average is 15. So now to calculate variance and deviation, we have a very useful table. And we need this table to do the calculation. So the top of the table, so that will be first is our X. So every number in the second row, right? And then X minus X bar, and then X minus X bar squared. Okay, so those are our 3 columns for this table. So we have 5 numbers, 1, 2, 3, 4, 5, and then the last one we use a sum here. Okay, sum here. So now my suggestion is you reorder the given numbers. Okay, we reorder the given numbers for this new table. Okay, for this new table. So first number is 5, and then 10, and then 15, and then 20, and then 25. Okay, yeah, you don't have to reorder, but my suggestion is you reorder it. Okay, it's easier to track mistakes or avoid mistakes this way, right? Yeah. So now what is X bar? X bar is 15, so the middle row is X minus 15. All the numbers in the first column, middle column. All the numbers in the first column minus 15, you got the middle column. Right? I will use the red number. Okay, 5 minus 15, negative 10. 10 minus 15, negative 5. And then we have 15 minus 15, 0. 20 minus 15, 5. 25 minus 15, 10. Okay, yeah. So you can use the property to check the calculation in the middle. Okay, so the sum of the middle column has to be 0. Okay, the sum of the middle column here has to be 0. Okay, yeah. It doesn't matter how many numbers are given, and then what's your average. So if your calculation is right, the sum is 0. And then because it's always 0, we cannot just use this difference, x minus x bar, to look to define variance and deviation. Okay, variance and the deviation basically measure how far the given x away from the x bar, the average. Okay, the average. So we square everybody in the second column. Okay, so this is the square column. So let's use the blue color. We square everybody here in the middle. So negative 10 squared, 100. 5 squared, 25. 0 squared, 0. 5 squared, and 10 squared. Okay, 10 squared. So negative sign canceled in second power. Okay, second power. And you add everybody in the third column, the last column, you get the sum 250. Okay, 250. So we will use this 250 to define variance and to define this deviation. Okay, deviation. So now what's the formula for the variance? Okay, what's the formula for the variance? So we use S squared. That's the notation for variance. So is this sum 250 in the table? Sum of squares divided by n minus 1, 4. Okay, so the formula is sum of squares over n minus 1. So here n is 5. We have 5 given numbers. So n minus 1 is 4. And then sum is in this table. Okay, let's do blue card again. Sum is the last one on the corner in the table. Okay, in the table. So S squared for this example is 250 over 4. Okay, over 4. So we got 62.5. Okay, 62.5. So that's, by definition, is called sample variance. Okay, sample variance. So what is the sample deviation? We use letter S, so that's the square root of variance. So this is square root of 62.5. Okay, so for the last step, you have to use a calculator, and it's a very bad number. Okay, it's a very bad number. It's 7 point something. Okay, it's 7 point something. Okay, if you round it to integer, it's like 8. Okay, it's like 8. 7 point something. Okay, so that's the end. So we have a lot of graphs and 3 formulas, 1 table for the calculation.